Our topic in this video is ratio and proportion word problems. You will be asked to solve a ratio and proportion word problem on your assessment. And in the directions for that, I will ask you to use a ratio and proportion setup, even though there would be other ways to solve. So it's important as you study to remember what is a ratio and a proportion is those two equal fractions, and to be able to set one up from a word problem. As I read through this problem, I read that a tablet contains 325 milligrams of medication, and I am asked how many tablets are needed for a dose of 975 milligrams of the med. You may have a concept of how to set this up because it is similar to the problems that were in your pre-lecture video. When I set up a ratio and proportion word problem, I want to pick items that go together to create my first ratio. So from the first sentence, I see that a tablet contains 325 milligrams. So I have one tablet equal to 325 milligrams. These are truly an equivalence, like we have memorized the conversions from centimeters to inches, etc., things that are equivalent. In the ratio and proportion method, we're going to make these into a fraction. It does not matter which one is on top and which one is on bottom, but you must be consistent. So I am going to set up all of my problems to have tablets on top and milligrams on the bottom. Now I said all of my problems, but I truly meant all of my ratios. So some people refer to this as my word ratio. And you don't have to write a word ratio, but it's a nice step in keeping your work organized. So my word ratio is tablets over milligrams. From the first sentence, I can fill in numbers. I have one tablet equal to 325 milligrams. Now, you may want to put labels in here so that you're being consistent with the setup. And you see that I have an equal sign between them. I don't have the multiply of dimensional analysis here, but rather I have an equal, and so the labels are at the same spot because I am setting up things that are matching or equal, which is very different than the concept of dimensional analysis where things are opposite. So because I'm setting things up to be equal, I will put another equal sign and another fraction bar. As I read the second sentence, it asks me how many tablets, and so on the top of my fraction where I am putting tablets, I'm going to put X because I don't know how many tablets. That's the question. And then they tell me 975 milligrams, and so I'm going to put that in the denominator because that's where the milligrams are going in my setup. Now, this shows my thought process. Sometimes it's easier to do the math without all the words, but I do have to take time to think it through and make sure I have it set up right, or the math isn't going to work. So from my thought process, I have the proportion 1 over 325 is equal to X over 975. Now, one way that I can solve is with the cross product. So I multiply diagonally. 1 times 975 is 975. Still using the equal all the time for proportion. Multiply on the other diagonal, and I have 325x. This little equation can be solved in one step. I will divide by the 325 to get the x by itself with a coefficient of 1. So these cancel, and x is equal to 3. Looking where the x was in my thought process, that is representing 3 tablets. The cross product method is not the only method that will allow you to solve. So let me show you a different method because it might have been what you were thinking. So my proportion is 1 over 325 is equal to x over 975. And you might have noticed that if you take 3 times 325, you would get 975. So if I'm going from the left to the right, this is 3 times larger. So if that's true on the bottom and the fractions are equal, that would have to be true on the top. So this would be times 3 as well, which would give me that the x is equal to 3 tablets, the same answer I solved below. You may have been thinking of other ways to solve, and there are many. The purpose of this video is to practice the ratio and proportion setup, which is a setup that I will assess you on when we get to that first assessment. So let's take a look at a second example. Again, as I read through this example, I am told to use ratios and proportions, so I'm looking for things that are equivalent that can go into a ratio. The first phrase of the sentence says, if 1 glass of milk contains 280 milligrams of calcium. So from that first phrase, I see that 1 glass is equivalent to 280 milligrams. And so this can create that first fraction of my proportion. So I'm going to make the ratio 1 glass over 280 milligrams. My word ratio is that I'm always going to put glass on top and I'm always going to put milligrams on the bottom. These are equal, so they are matched up as far as labels. Reading the second phrase, I am asked the question, how much calcium? So the calcium is what was measured up here in milligrams, and so the thing I don't know are the milligrams, so I'm going to put an x as a variable in the denominator. I keep reading, how much calcium is in 1.5 glasses? So the 1.5 glasses of milk goes on top because that is where my label of glasses is going. So that is my thought process in setting it up. Now I can pull out my proportion. So I have the fraction 1 over 280 is equal to 1.5 over x. I'm going to solve by cross product, and so multiplying on the first diagonal, 1 times x is just x. I do not have to write the coefficient of 1. Put in equal. Multiplying on my other diagonal, taking my calculator, I do 1.5 times 280, and my calculator told me 420 milligrams. Let's take a look at one more. Again, I would encourage you to pause the video here and try this on your own before you listen to me do it. Again, if we were together face to face, I would have you do that. So I want you to try it and then come back and see if your setup matched mine and if you got the same answer. So for this one, I read at the first sentence, 6 milligrams of med in 4 tablets. So 6 milligrams equals 4 tablets. They are equivalent. So I'm going to make my word ratio have milligrams over tablets. So I have to match that the whole way through my setup. So from the first sentence, 6 milligrams equivalent to 4 tablets. Put my equal sign. I want to make another equal fraction, and it asks me how many milligrams. So that's the question, and so I'll put an x milligrams on the top because that's where the milligrams are going in my ratios. And it's asking for a half tablet, so 0.5 tablets. So there's my thought process set up with the labels showing how I'm making equal fractions, which are equal ratios, which are called proportions. So my proportion that I can pull out of here is 6 over 4 equals x over 0.5. And I'm going to solve with the cross product. So I'll multiply on this first diagonal 6 times 0.5, and that gives me a value of 3. Put an equal sign. Multiply on my second diagonal, 4 times x is 4x. And then to finish out, I will divide by 4 to get the x by itself, getting that coefficient for the x to be 1. So x equals, and when I look at what I'm solving for, I'm solving for milligrams. Milligrams are metric. And as we learned in week 2, metric needs to be given with decimals, not fractions. So I'm going to take on my calculator and type in 3 divided by 4, and that will give me that x equals 0.75 milligrams.